Mm. Replace these with open source apps. Okay, sure. What the fuck? Concrete keyboard? What the fuck are they doing? Okay, to get a junior analyst role.
Here is everything you need to know as a security analyst. Get out your text editor of choice and start taking notes. Sublime is better than VS Code. Write that down, write that down! No, no. But seriously, I've come a long way since my first security analyst job, and I've done enough malware battles.
Hooter, use CrowdStrike.
Okay, I think I would also be needing. Okay, is it just me or do I feel like my laptop is working a little slow? I think, but the thing is, like, it should not work slow because now I'm gonna put it through more, like, different states. This, so even I'm not sure. Sure not.
Security analyst. To security analyst work should know to even remotely have a shot at landing a job these days. Let's begin. Now, if I left anything out on this list, please comment down below. It's going to help everyone if you comment. Computer basics in every operating system. How are files stored? What is the file system like? Have an understanding of different file types. Zip, rare, executables, CTFs, CSVs, BAT. I live in the shadows. All the types.
Identify as a JPEG.
He lied to me. What do all these processes in Task Manager do? Now, you don't have to memorize them, but you do have to know what the actual is going on here. What the purpose of a Windows registry is. What parts of the registry control what things. Like startup processes, as in the processes that start up when you boot up your computer. What are device drivers? What do they do? Why are they needed? Where do newly installed programs go on all operating systems? And where are all the remnants of said programs? Linux commands, Linux file paths. Where are the passwords stored? Where do user accounts live? And for Mac OS, know that it exists. Did you learn how this operating system works? I guess, but these are not targeted very often, largely in part due to how, by default, they are less customizable than Windows, all because Steve Jobs is a pretentious who was like, my design is perfect, no one shan't change it. How programs, software, applications, scripts work. After all, operating systems are just convoluted and complicated scripts running in tandem. At the end of the day, code is just made up of zeros and ones. All they are is dust in the wind. Beyond how the computer's operating system and programs work, you need to, of course, know networking. What are IPs? What are IPv6s? Because, by the way, we used all the available IPv4 addresses in 2019. How are these IPs assigned? And why is it important to how the internet works?
Behold, the internet!
My God, it's full of ads.
Subnetting, specifically how are networks broken up using subnetting, and VLANs. How do networks traverse the internet via protocols like TCP, UDP, ICMP, TCP, LTP? Those are VPN related. Why does my mom not know how to reset her router? Typically built-in security tools like firewalls and built-in operating system antivirus. Looking at you, Windows Defender. You suck. Actually, it's pretty good. How do firewalls prevent and identify stinky bad doo-doo faces trying to get into our network and drop their malware load? Very basic understanding of how to use and how security tools like SIMs, EDRs, IDS, IPS, packet inspecting tools like Wireshark, and network and computer scanning tools like Nessus, Nmap, etc. How do these work? Again, very basic understanding of these tools. As in, you did a module in TryHackMe, and you can explain it like I'm 5 to people in job interviews. Knowing how they work is important because if your security tool, your SIM, your EDR, identifies such activity as scanning, then it's good to know what that is. Anything that is related to cybersecurity requires problem solving and the ability to quickly research and learn something you don't 100% know. It's impossible to memorize how everything in the tech space works. There's too many goddamn software and security tools, we can't just learn them all. But being able to research and learn quickly on the fly is critical.
Moist critical. Put this input, calm down, you calm down!
So again, the basics. Do you need to know how to configure a SIM or EDR? Hell no. But that's the security engineer's job. Do you need to know how to click around in the user interface in your SIM and EDR? Yes, yes you do. But that's child's play, and that's why the security engineers make more money. They set up the tools, and security analysts just use the tools. Again, TryHackMe has modules for that. Easy peasy, lemon squeezy. Hacking is easy. Come on, get on there, folks. But knowing the basics is only important in learning the TTPs.
Time to penis.
No, not that. No, that is funny, but not that. These are the tactics, techniques, and procedures that malicious actors utilize and use in a cyber attack. Now, 50% of the job is knowing how the things work, and the other 50% is knowing how those things can be exploited and maliciously used to achieve their goals. While the list here is comprehensive, don't worry, it doesn't take that long to memorize. You just need a good mnemonic device. My favorite mnemonic device is Google. So all the hard work you did to learn the basics is now then used to understand how files, file paths, registry paths, scheduled tasks, networking protocols, ports, packets, what have you, all the things can be used by malware, viruses, that one crazy hacker to effectively gain access to a computer if you're a hacker, or to spread and infect as many endpoints in the environment as you can if you're malware.
Please! God damn it! Hate this hacker!
While hackers have typical methods of gaining access and keeping access, you should also understand how usually the biggest threat as far as infection to an endpoint is different schools of malicious code. It's usually not going to be a zero-day attack from Korea or Russia. We're talking about viruses, worms, ransomware, Trojan horses, spyware, adware, rootkits, fileless malware, and every other malicious code that can make it to your pooter and make your security team go or nar, or nar. And lastly, the things that you need to be aware of once you know all those things is
All
obviously
right.
core principles of security.
So I guess here we are, and we will be moving towards learning about cybersecurity, as the name dictates. What's the name of this? Becoming Mr. Robot Learning Cybersecurity with CTFs. So the thing is, that's exactly what we are going to do.
I'm Jason E. Street.
Too many things. Okay, no thanks.
I created a capture the flag challenge called Curly Fries. This was a miscellaneous task in the NomCon Capture the Flag 2024, the 5th time we've hosted that game. A ton of fun. And this is a privilege escalation challenge with a special thanks to Tiberius, who gave me the inspiration for this after he had kind of an interesting solution for the end of bookstore, which is another challenge I created for Hacking Hub. I can add a link in the description if you're interested in that. But looks like all we need to do is escalate our privileges and run the program in the root user's home directory. Now, this required an SSH connection. I am running this locally because we have now turned down the infrastructure for the NomCon Capture the Flag. I will try to get the challenges up and available for you in another location, but in this case, I will go ahead and SSH into my local host, just hosting the challenge for us to work with. The prompt included the credentials user being the username and user pass as the password. Now, if we were to ls inside of this directory, I am just user at curly fries as the host, but there's nothing really here. There's not a whole lot to go off of. However, it is a privilege escalation challenge, which might clue us in that we could use sudo. Super user do, hey, try to run things as the root user. We could use tac-l to list what commands we might be able to do. Now, our user may do the following. Looks like we could run as the user fry, hey, that entity, that identity that we wanted to at least try to gain access to before we got to the root user. And without a password, we could run the curl command. That utility to access a lot of web URLs, right? Hey, actually
Okay.
access the internet, make HTTP requests. But this seems like we could only request something on localhost. So 127.0.0.1 as the IP address on port 8000 and only going to a health check.
I need to buy a new mouse. Where can I get a cheap mouse? But a good one. This looks funny. The fuck is this? Don't want that, don't want that, don't want that. I want something like this. It's good, but I'm pretty sure that's gonna suck ass. So let's move on. Frontech. That's a name that I've heard. Let's go with mouse. This is something which I can go for. Not this. Actually, you know what? What would be more simpler? Actually, just going out and buying a new fucking mouse. That will be actually be cheaper for me and a little better. So yeah, and I don't have to wait for some motherfuckers to arrive.
So before we even run this with sudo, we could just straight up curl. Look, do we even have anything running on port 8000? No, in this case. I think we might be able to use SS or netstat. We don't have any of those installed. Oh, okay. I guess we have netstat because we're in an Alpine Docker container. But at the very least, we don't have a host actually being served, anything actually accessible on port 8000 because I intended you to just spin up your own HTTP server on port 8000. So we could simply just run, I believe we have Python 3 in this case. Yes, we do. So Python 3, which means we could use tac-m to specify a module that we want to run, and it does have the built-in HTTP module. .server will allow us to simply host a HTTP server on port 8000 by default. That keeps it easy. With that, we could then access that on port 8000. Problem is, and actually I will need to create another terminal if I were to do this, so I'm going to drop down with Terminator just to get another shell. Once again, enter the password, and now I could curl HTTP if you want to include the schema. I believe it'll add it by default. My microphone is in the way, and I can't even read my keyboard because I do occasionally look at the keyboard to see where the number 7 is. Now that's not all that helpful. We get a directory listing that's just the default natural, hey, functionality of a HTTP.server hosted with Python. However, we could run with the sudo tac-l reference anything going to /health check. So if we were to create a file, we could just simply, you know what, we should actually host probably out of the temporary directory. Maybe that's fine for us. We can make a directory for like dub, and that way we can run the exact same Python 3 HTTP server in that location. Let me get back over there in the other shell. So I could just do a please subscribe with typos and everything in that health check file. Now I could end up running curl HTTP 127.80.0.1 port 8000 for the health check file.
curling that down, we get our please subscribe, okay? But again, that's not all that helpful to us. We could do a little bit more enumeration, see what else is on the box, knowing that at the very least from the sudo output, without having any other reconnaissance intel here, we know that fry is presumably a user. So let me get to this terminal all maximized. Obviously, if we were to take a look at it, set our password, we do have a fry user available to us. So what we might be able to do, instead of using health check as just a temporary file that we create, we could create like a symbolic link. We could actually use ln tac s to create a linked file that will point to another file. This is what I had intended for you to be able to do, to actually get the health check file pointing to something else on the file system. If I were to create a health check based off of anything that fry user that we knew from its set password is in home, if they're an interactive user, they might have history. Hey, the commands that they ran from the terminal. And that's clued in from the challenge prompts. I note, our friend Fry has been typing at the keyboard and running all kinds of commands, but his fingers are dirty. So we could try to get their bash history file. Now, I don't know if I have that syntax right. No, I'm always getting that wrong. I do always get the parameters wrong, so I have to actually swap those. The order is different. It should be the bash history file first, and the file that we want to create health check following that. Now, we should have health check in our current directory. ls-tac-la would tell us, let me zoom out a bit so it's actually visible for us, health check is pointing to home_fry.bash history. With that, we could use curl, now again, with that being hosted on our port 8000, just a simple sudo tac-u to operate and act as that user fry, curl 127.0.0.1.8000 to our health check. Now, when I hit enter on this, there we go. We get to read their bash history. Okay, some nonsense in here, but we do get to see SSH pass being used, which usually supplies a password for SSH connections with tac-p, which clues us in that I love curly fries, yum yum in my tum-tum. You can clip that. That's the password for fry as our user. Now, I gotta admit, I think I had maybe muffed up the permissions. I think even this user as we are now could just straight up read fries.bash history file without needing to use curl. Yeah, I think I just had like the settings. I think I had the permissions on that one modified so that would ensure and work. But yeah, anyone could read their bash history file. With that though, we do now know fry's password. So let me SSH in both of these shells to fry at localhost with their password. And there we are as that fry user. I'll do that once again down here just so we have a second one rolling for us. And now we can start our enumeration reconnaissance. Hey, maybe looking around the file system all over again. However, there's not a lot to dig into. Before we keep cruising though, I would like to give a special shout out and some love to the sponsor of today's video. There's a button and a link this here. You can see actually a whole sudo tac user, but there wasn't more to dig into in their home directory. Again, we are trying to escalate our privileges, so why not, once again, we take a look at sudo tac l. Looks like Fry, the user that we are, can run commands as root without a password. In the case of curl, once again, 127.0.0.1 port 8000, health check again, except this time with an asterisk, which means we can supply basically anything else that we want for curl. We could keep adding on to the end of the command, keep trying to add other arguments or parameters or things we might be able to do. With that, maybe we were to actually take a look at curl. Okay, I guess inside the Docker container, we don't have the man pages for the manual for curl, so let me open up just another terminal on my host, and let's take a look at the man page for curl now. Curl is to do some transfer with URL, and you can supply any options or URLs as you would like, a little bit more description, and then way down below, you can see all of the other arguments, parameters, flags, switches, whatever you really want to call them, for other functionality that you might be able to do with curl. This is quite a hefty man page, so there's a lot to read through if you wanted to explore all of it, but I will speedrun us right towards the solution here, because we could very well just get back to the terminal here, use curl as we would have, maybe with sudo. We'll use sudo tac-u root in this case, 127.0.0.1 port 8000, and we'll need health check once again. Now, we don't have anything actually running on port 8000, remember, right now. If we actually move back into the temporary directory in our other session, let's make just another serve directory, so we'll have something clean to work in. I'll use python 3 tacm http.server once again, so we'll spin that up on port 8000, but we should actually get some files over there. So let me get over to temp serve, and we could create health check if we really wanted to, but we could also just, I don't know, actually add on to the command that we're already building out with sudo here. Because remember that asterisk that we saw in sudo tac l output told us we can just keep adding whatever we want at the end. It's a wildcard. So what's to stop us from just actually trying to read a local file? We could use the file schema rather than like HTTP as we might if we were trying to actually access our 127.0.0.1, right? HTTP or HTTPS is usually the schema there, but there's nothing stopping us from doing the same thing with file and then trying to access anything we want. We could actually, I guess, close down this HTTP server because we probably don't even need it, right? Could we go ahead and read something like etc. shadow? That is something that only root would be able to read, and it looks like we can. Etc. shadow, which will include all the password hashes for different users. This is an option, and we could try to crack the password. However, it's a bad option. It might take too much time. We might not even get the password hash. It could be anything, so that's not ideal. But we could do more with curl, because why not try to save files the same way that curl usually allows us to add outputs with tac-o. We can store and save the contents in any other file that we might like. If we try to use that, will we get health check as the first thing that we requested, which we know errored, or the file that we know errored? What could we do here? We could save a file. We'll put this into temp serve. I know we're already in that location, but we'll call that file like log. Now, if I ls, do we have anything? No. Is that because that just failed? It might be. Let's add another tac-o just to see, can we save something else, like the second thing that we request? Could we put that in temp serve data? How about that? Oh, that seemed to do something. Now we have data. And if we actually were to take a look at that file, it is etc. password. So we have arbitrary read now as the root user and arbitrary write where we can output this. However, only arbitrary in that, okay, it's something that we would have to get from the output of curl. So curl has to be able to see that from someplace else. But we just learned the trick in the previous step, going from the user to fry user. We could just simply host whatever we wanted to on port 8000 for our health check and then put that as our file to write. Now, I know we can think outside the box here because this is SSH. We've connected as Fry. So I'm curious, does Fry have SSH keys in .ssh? No, it doesn't. Okay, so let's use SSH keygen and try to generate our own ID RSA or public and private key pair to log in through SSH. Would that work, right? ls-tac.la.ssh. Now we have those files created. Do I actually have SSH present here? I do. So I could SSH into just
fry at localhost, correct? Yes, it would prompt for a password, which we know, but could we actually, inside of the .ssh file, put the public key that we'll end up using into the like authorized keys folder? Like, we have our public key, right? So what's to stop us from now using that as our authorized keys file, just as a proof of concept? That way we could try to SSH with our own public and private keys in
I just missed it. Wait, I was thinking of something else. What the fuck? Dude, I have been silent for so fucking long. I did not even realize this. I seriously did not even fucking realize that I was silent for so long. It was. Dude, we can do. What the fuck? We can do this? Bro, that's something which I just learned.
it doesn't. Okay, so let's use SSH keygen and try to.
I think I should note it down actually. So, just so that I'll have some notes. That's not the right one. What the fuck is my right diary? Which I noted down all of these shits. Yep, nope, that's not it. Is it air? Nope. Nope, 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 no. Where the fuck did I keep that? Howdy. Howdy, gentlemen. Found it. It's a little far. Okay. Come back right here.
Just do a please subscribe with typos and everything.
We have
in the
done
description.
this.
But now let's get back to our curly fries challenge because we /intro lab training always up. If you go to and you can say to the course completely available, completely for free, just on the internet. You can go to github.com/strandjs/intro labs, and if you dig into
There we go. So basically, these are.
absolutely
What are
genius,
these
incredible,
again?
phenomenal, fantastic people. And John Strand actually puts out a ton of these intro labs out and about on GitHub, completely available, completely for free. Machine at sudo tacl. Looks like Fry, the user that we are, can run commands as root without a password. In the case of curl, once again, 127001 port 8000.
Okay, I need a new fucking mouse. Alright. I need a new mouse, man. I don't want to spend my money right now, but I want a new mouse. Straw hat. Member is closest to Zoro.
Health check
Don't want to
again,
know.
except this time with an asterisk, which means we could supply basically anything else. Maybe we were to host and let's more description at the end of the command. Keep trying to add other arguments or parameters or things we might be able to do. With that, maybe we for curl. We could keep adding on to the end of the command. Keep trying to add other arguments or parameters or things we might be able to do. With that, maybe we were to actually take a look at curl HTTP as because we probably don't even need it, right? Could we go ahead and read something like etc shadow? That is something that only root would be able to read, and it looks like we can. Etc shadow, which will include all the password hashes for different users. This is an option, and we could try to crack the password. However, it's a bad option. It might take too much time. We might not even get the password hash. It could be anything. So that's not ideal. But we could do more with curl. Because why not try to save files the same way that curl usually allows us to add output with tag O? We can store and save the contents in any other file that we might like. If we try to use that, will we get health check as the first thing that we requested, which we know errored, or the file that we know errored? What could we do here? We could save a file. We'll put this into temp serve. I know we're already in that location. But we'll call that file like log. Now, if I ls, oh, do we have anything? No. Is that because that just failed? It might be. Let's add another tag O.
Why does I feel like it's lagging? Like it's. Something is wrong here. I can feel it. I can feel it in my gut. Why the fuck is my GPU so high? Okay, Nvidia. Understandable. I can free my memory. Everything looks normal here. I have an extreme performance game mode on. That's true. That's true. Firefox. Not only Mozilla Firefox. Actually, I also want that thing to be treated as a game, which is called. Fuck is this called? I forgot. VirtualBox. Oracle VirtualBox. This one. VM VirtualBox. VM. Which one of these two? Uh, I need to find it. No more options. Properties. VirtualBox.exe. Alright. So I want program files. Go to Oracle VirtualBox. This one. I also want this to be treated as a game. But everything that comes out of this will be going to treat it as a game and will be given a high performance rate. Cool. So this is there. Game highlights. Don't want to bother even with this one. Don't care. Live updates. The thing is, I also need a new. What is this? Utility new. Mystic lights. What the fuck is this? These many things are already installed. Great. Intel graphics, Nvidia graphics driver, whatever, blah 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 blah. Utility Mystic lights. I have no idea what that is, and I'm don't gonna fuck around with that either. Moving on.
Just to see, can we save something else? Like the second thing that.
Okay, so which command did he use for server? He used a command for server. Which one was it? Python m no. Python 3 m dot http server, right? http dot server. All right, moving on.
What's to stop us from just actually trying to read a local file? We could use a access something that only it's not a bad
This.
function. It might take too much time. We might not even get the password hash. It could be anything. So that's not ideal. But we could do more with curl because why not try to save files the same way that curl usually allows us to add outputs with tag we can store and save the contents in any other file that we might like. If we tried to use that, will we get
He also used another technique, which was pointer. He used pointers for Linux. Right, I also want to know what the fuck these are. Not this pointers, you fucking ass.
One of the hardest things for new programmers to learn
Not this, not this, not this. He created a pointing directory for this.
the temporary directory. Maybe that's fine for us. We can make a directory for like dub, and that way we can run the exact same Python 3 HTTP server in that location. Let me get back over there in the other shell. So I could just do a please subscribe HTTP 127.8001 port 8000 for the health check file. Curling that down, we get our please subscribe. Okay, but again, that's not all that helpful to us. We could do a little bit more enumeration, see what else is on the box, knowing that at the very least from the sudo output, without having any other reconnaissance intel here, we know that Fry is presumably a user. So let me get to this terminal all maximized. Obviously, if we were to take a look at it, set our password, we do have a Fry user available to us. So what we might be able to do, instead of using health check as just a temporary file that we create, we could create like a symbolic link. We could actually use ln tac s to create a
Symbolic link. This is something which I actually wanted to learn about. Symbolic links.
In this video, we're going to go over what a symlink is and how to create one. So essentially, a symlink stands for symbolic link. And
Creators.
that will point to another file. This is what I had intended for you to be able to do, to actually get the health check file pointing to something else on the file system. If I were to create a health check based off of anything that Fry user that we knew from its server password is in home, if they're typing at the keyboard and running all kinds of
How is this soft link? Yes. Yes. Now, is this also in this book? I want to know if there are symbolic links in this. Security issues. Role of device driver, splitting the kernel, class of device. Okay, I'm gonna do this. Linux device drivers, the third edition. I think it's already here, right? The only problem is that I cannot do. कैटलॉग भाई मेरे उसमें सॉफ्ट कॉपी तो क्या ना ऑफिस में उसमें पड़ा हुआ ना लैपटॉप में मैं यार किसका वो वाले का कैंट वाला ना हाँ हाँ Okay, so I'm back. Or something. Sometimes I just hate my office life. Oh, okay.
commands, but his fingers are dirty. So we could try to get their bash history file. Now, I don't know if I have that syntax right. No, I'm always getting that wrong. I do always get the parameters wrong, so I have to actually swap those. The order.
Not pointer, I want. Yeah, now I remember. I was actually checking if Linux device drivers have anything about these. Yep, this is the same one. Did they get any matches? Symlink, now we talking about 412. Alright. If a page function, that's the first one. That's it. First one is at 412. Oh, 112. Memory data mapping, blah blah blah. The TTY driver structure. The TTY driver structure. It's 546. It's at the end. 546. Not this, man. Come on. Seriously. Which is this? Chapter 14 Linux device model. So it's around 300 and something. It's around 394. That's the problem. Here we go. Okay. So what does it say now? That's the question begins. Add a device, PC, so fuck my. What is it putting it all together? That's the question. If the PCI driver flow function determines it cannot be handled this device for some reason, it runs to negative error values. The code and cost to corner continue looks through the list of drivers. There should be some before. Uh, symbolic link 1. Oh, we have one. It's 375. 370. We have a whole chapter dedicated to this one. 374, 75. Symbolic links. Now I got it. Alright. Where my highlight is. Gonna need that one. I require this, and I also need, if I can find my fucking pencil. I bloody hope my pencil is not fucking someone. Or maybe it is, because it's not here, so I don't know where the fuck it went. Seriously, what the fuck, man? Oh, what do you want? I don't want to use pen on this. I want to use a pencil. But I don't know where the fuck my pencil is. Yo, what the fuck? Where the fuck did my pencil go, man? Found it. Alright, let's study then. Symbolic links. Well, there's also one. The first one is here. The first mention of symbolic link is in compiling modules. Which chapter is it? Compiling and loading. Yes, once again we are seeing the extended GNU making a syntax in action. Try to locate the kernel resource directory, take advantage of the symbolic link build and install module directory, the point back. Alright. The SYSFS, the SYS file system, has usually tree structure reflecting the hierarchical organization of the key co-object it represents. What? Is this even English anymore? The relationship between object and the kernel are often more complicated than that, however. For example, one SYFS subtree sys/devices represent all the devices known to the system, while other subtrees under SYS bus represent the device drivers. These trees do not, however, represent the relationship between the drivers and devices they manage. Okay, showing these additional relationships requires extra pointers, which in SYSFS are implemented through symbolic links. Okay, creating a symbolic links within SYFS is easy. Interest, blah 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 blah. Okay. This function creates a link called name pointing to the target system entry as an attribute to kObject. It is a relative link, so it works regardless of whether SWF is mounted to any particular system. The link persists even if the target is removed from the system. If you are creating symbolic links to other co-objects, you should probably have a way of knowing about changes to those co-objects, or some sort of assurance that the target co-objects will not disappear. The consequence that symbolic links within SFS are not particularly grave, but they are not representative of the best programming style and can cause confusion in user space. Okay. Symbolic links can be removed with remove links. Alright. Okay, to be honest, no fucking idea what this means. Please, anyone fucking enlighten me about this. I think I have to go with this then.
Linux links. So, for every file in our file system, there exists an index node or an inode. An inode is like a database of a file. So,
Okay, first of all, what the fuck is SYSFS system? Okay, SY is the file system for exporting kernel objects. What it is, SY is a RAM-based file system intentionally based on RAMFS. It provides a means to export kernel data structure, their attributes, the linkage between them, user space. SYSFS. I won the first match. I think it's gonna be in the starting of this. Okay, there's too much about SYFS. I think I should know about what the fuck this is at this point. Okay, what's the first match? USB and SYFS. So this is the first match that we went through, and this is the second match. Alright, so file system. Loading and unloading modules. After modules, the information on currently loaded modules can also be found in SIS virtual file system under SYS module. Shouldn't this be somewhere in the introduction, like what the fuck this is? What it is? SYS is a RAM-based file system initially based on IOS. Okay, I think I should also know this. What the fuck? How have I learned Linux without knowing all of these things? SYSFS. It's a 16-minute video. UDEV dbus.
Hi, I'm DJ Ware. On this
System
episode
file
of the Cyber
system.
Gizmo, we're going to be talking about sysinfo. We're going to also be talking about some other things like /proc and also bus, and talk about how all of that interfaces in and works with Linux and the Linux kernel. Right after this. It's kind of unique on how all of this works. So we're going to look at the tools that are used to list and manipulate devices, but we're also going to be looking at those tools for how the Linux kernel gets its data structures and be able to push that memory into userland for applications in that space to be able to pick it up and use that data for its own purposes. Some of the data is modifiable and some of it is read-only. So we'll talk about that, and we're also going to be looking at USB devices and how those work. And then we'll take a look at how sysfs and /sys/proc and the bus structure works in a little bit of detail, and try to help explain that to you. But the first thing is, these are really virtual file systems for hardware and system information is what these are. So Linux uses several structure works in a little bit of detail, and try to help explain that to you. But the first thing is, these are really virtual file systems for hardware and system information is what these are. So Linux uses several. These are really virtual file systems for hardware and system information is what these are. So Linux uses several virtual file systems that provide in-memory look at your system, and that is a means that it uses to communicate with user land. So there's nothing actually written to your storage device. They all sit in memory. So those virtual file systems provide you with an insight into the kernel data structures and into the system hardware that your machine is using. So sysfs, that was created by Patrick Mokel, and it was introduced into the Linux 2.6 kernel. Patrick has a paper that he wrote years ago called the sysfs file system. The sysfs is a file system. This is his words. The sysfs file is a file system that allows kernel subsystems to report kernel objects, object attributes, and object relationships to user space years ago called sys that your machine is using. These are really virtual file systems for hardware and system information is what these are. So Linux uses several virtual file systems that provide in-memory look at your system, and that is a means that it uses to communicate with user land. So there's nothing actually written to your storage device. They all sit in memory. So those virtual file systems provide you with an insight into the kernel data structures and into the system hardware that your machine is using. So sysfs, that was created by Patrick Mokel, and it was introduced into the Linux 2.6 kernel. Patrick has a paper that he wrote years ago called the sysfs file system. The sysfs is a file system. This is his words. The sysfs file is a file system that allows kernel subsystems to report kernel objects, object attributes.
I still don't understand
File systems
shit.
for hardware and system information is what these are. So Linux uses several virtual file systems that provide in-memory look at your system, and that is a means that it uses to communicate with user land. So there's nothing actually written to your storage device. They all sit in memory. So those virtual file systems provide you with an insight into the kernel data structures and into the system hardware that your machine is using. Those virtual file systems.
Kernel data structure to system hardware. Data structure and your system hardware. These are virtual files because there is nothing actually written to your storage device. These provide an insight into the kernel data structures and your system hardware. I am still not sure what the fuck these are. Okay, I know there is something which we do here, but I'm still not sure what it is. Fucking hell, what the fuck is this? Not this, not this. Where was I? Okay, here. Do not understand. SYSFS Linux. Can somebody please explain it to me like a fucking 5-year-old? Okay, now there's a person.
Hello? Hello,
With a
everybody.
bad audio, of course, this is gonna be good.
Linux sysfs file systems. Let's start with the board using the
This is
sysfs.
first.
Maybe we can start with that, how we can access
This
the
first.
system information, and then how we can write into the peripheral, and how we can read back the information using the sysfs. Basically, sysfs is something like a We can say it's a pseudo and virtual file system similar to procfs basically. Procfs contains limited set of data. Instead of that, sysfs contains more information about this system, bus, and then devices, and then different kind of classes, and different kind of file system, and different kind of network, and different kind of process. All the informations we can able to see.
Okay. A pseudo virtual file system similar to procfs provides an interact to the kernel data structure. Okay, so it's interacting with kernel data structure. But now the question is, it's what the fuck? Why? Okay, so we have a kernel data structure. So I believe like to pass on the information of the kernel data structure, like whatever the data structure that the kernel is handling, like all the files are being handling. I think sysfs is connecting towards that. But I'm confused with all of these things. What the fuck?
Using the sysfs. Basically, sysfs provides an interface to interact with the kernel data structures. Basically,
Alright.
whenever we are using that driver, developing a driver, maybe we can provide that user access to read back. For example, maybe we can take an example of temperature sensor. We have to give three things maybe, that the value, current value, minimum and maximum threshold. The minimum and maximum threshold can be written and read back, and then the value, the current value of the sensor that we have to is the only option of reading.
What?
Maybe we can take an example of temperature sensor. We have to give three things maybe, that the value, current value, minimum and maximum threshold. The minimum and maximum threshold can be written and read back, and then the value, the current value of the sensor that we have to is the only option of reading. Something similar to that. According to that, our need, the sysfs can be used as a read or write basically, and also it provides the complete information about that devices, kernel modules, and then file systems basically. And it has commonly mounted in the slash sysfs sys, and also you can manually mount that sysfs file system in the root mode using mount -t sysfs slash sys. And it has the different arguments that you can define in your Linux kernel drivers that will allow that write or read the kernel variables based on the parameters. And basically, it involves more symbolic links, so that, for example, bus can have device, the device can be present in the bus, so that all the things will go and link accordingly. Yeah, that we will see basically. And we have the different files and directories that we can able to see. Something like sysblock, maybe we can see here. I have that udo terminal over here. Maybe I can go to sys, and we have the block that it contains block devices information. Maybe we can see I have the block. Inside the block there is multiple loop devices which can be used for looping, creating a virtual block systems basically. And we have mmc block 0, which is that our micro SD card basically. Here we can see that our
Something is happening to me. I cannot concentrate for shit. I need to concentrate. But I'm not able to concentrate. I don't understand why. The thing is like it's important for me to concentrate because I have to learn this. नहीं मोबाइल नंबर मत बता एक सेकंड ना Ah, will the chat rate change if I send some messages from my own? I don't think so. That's how it works. So, moving on. Actually, I need to remove these chats. Where do I get this? Ah, these are not from here. Delete. Remove. Okay, so the thing is, I actually wanted to add the chats in mine. I'll have to switch my account to move towards the other one. I will have to go back to my channel, view your channel, go here, pause this. I need to, now this, I want to pop out chat so that I can take this and I want to add another browser chat YouTube. Okay, and instead of this I'm gonna give it to this and okay, this looks ugly as fuck. Change its width though. I'm gonna go with 200, I believe. Will that be fine? Too small. 300. That's good. I also want it to be transparent. Why is it not transparent? This is some another issue that this have. Shut down the source when not visible. Refresh browser when seen become active. Okay, I need to check something. Cancel. Where would the message show up? Alright, so I have to keep this. I can just remove this part. I have to remove the top chat as well. Okay, I think 200 is a good size for this. The chats are not coming full. I don't want this. Ah, shit. I don't know why the pop-out never works. For some reason. Some absurd fucking reason. The pop-out never works. Twitch account. I want to go to this one back so that everyone that I refresh does not go back to that. Oh my god. Dude, he has so many bots and I need to figure out why there are so many bots. This is fucking bullshit. And plus I'm not understanding how.
Hello everyone.
Hey, I see someone is on the chat. Is it someone or is it just showing me that when I open my own? I think when I open my own, that's what it's showing. But if there's someone in the chat, please say hi. I would love to talk to someone to understand what the fuck is going on. Even I can't understand this shit, man. Come on.
Let's start with the board using the CTFs. Maybe we can start with that how we can access the system informations, and then how we can write into that peripheral, and how we can read back the information using the CTFs. Basically, CTFs is something like we can say it's a pseudo and virtual file system similar to procfs. Basically, procfs contains limited set of data. Instead of that, CTFs.
Okay, I think I need to learn what the fuck the procfs is to understand what sys. That's another loop. Procfs. Unraveled tutorials, special file systems.
What is up, guys? Welcome back to part 2 of our adventure through the cosmos of developing a driver for the Raspberry Pi. In this tutorial series, I'm showing you guys how to make a driver for the Raspberry Pi that has access to the peripherals of the GPIO interface. Now, I know these drivers already exist. This is unnecessary work, but I think it's a really good teaching point on how to make drivers on unable to use it. So in this video, we're going to be talking about how we create an interface into a kernel mode driver. So if you remember in our previous video, we were trying to access the address down here, OX3F200000. This is the address of
Okay, the
GPIO
audio
interface
is good.
in physical memory. The problem, as we talked about before, is that by trying to access this address from user space on the Raspberry Pi, we illegally cross two boundaries. We legally cross the memory boundary between user space and kernel space, and we also legally cross the memory boundary between kernel space and actual physical hardware of the GPIO. So to solve that, we create drivers, and drivers provide this kind of seamless interface where we can close our eyes and go touch that part of the processor and not get yelled at by the processor, right? So the question is then like, okay, we have this driver, but how does user space actually talk to the driver to get access to kernel space? And the way we do this is using two kinds of methods. There's one called a device file. Device files live in /dev. They look like a file, but they're not actually a file. They're a special file that maps into the kernel and provides read, write, etc. functionality into the kernel that the kernel can then do things with that input from the user space. The problem with that is that device files are meant to map to a single physical device, right? So if you look at like /dev SDA or /dev TTY USB0, they are meant to map to like actual physical things. They're called device drivers because they map to devices. Now there's a different system we can use called the procfs file system. And the procfs file system is actually meant to do more generic things, not mapped particularly to a single hardware interface, but instead more generically used to provide info about the OS to user space from the kernel, and then act as a control interface for more generic software type things. So for this tutorial, we're going to be creating a procfs file from the kernel, and then act as a control interface for more generic software type things. So for this tutorial, we're going to be creating a physical things are called device drivers because they map to devices. Now there's a different system we can use called the procfs file system, and the procfs file system is actually meant to do more generic things, not map.
I intend to map to a single device. Intended to map to a single device. Procfs files lives in a process. Proc acts as a file, more generic, used to provide info about
particularly to a single
OS.
hardware interface, but instead more generically used to provide info about the OS to user space from the kernel, and then act as a control interface for more generic software type things. So for this tutorial, we're going to be creating a procfs file in /proc that we can read and write from, and it will provide output and input to the kernel mode driver that will control the GPIO interface. It is
Hello? I have to learn. I have to learn. I have to learn.
To give an example of what the proc file system looks like, I'll pull it up real quick here in my VM. I'm going to turn off my Raspberry Pi for a second. It's still on, just running in the background. So we'll go to /proc. You see a bunch of files here. None of these are actual files. These are actual all special mapped interfaces to the kernel that do certain things for us. If I do like cat procnet TCP, that call actually goes into the kernel. The kernel parses all of the connections that are running on TCP, and then we get this output here that goes to user space. So it feels seamless. It feels like a file, but it's actually not. So we're going to go on a Raspberry Pi and make a low-level learning GPIO procfs entry that will take our data and parse it, and eventually it'll control the GPIO interface via that. So what I'm just going to say, hello, cool, here's your data. Okay, we're going to give it 7 bytes of instructions to create the.
Okay, this is something. Okay, I understood that.
Context. More information.
So basically, it looks like a file, but the thing is, when you run it or execute it, it's actually gonna give you. It's gonna run like a fucking command or like a uh, program.
About this system, bus, and then devices, and then different kind of classes, and different kind of file system, and a different kind of network, and different kind of process. All the informations we can able to see using the CTFs. Basically, CTFs provides an interface to interact with the kernel data structures. Basically, whenever we are using that driver, developing a driver, maybe we can provide that user access to read back. For example, maybe we can take an example of.
And taken off and watch something else. Actually, I think I really require sleep and a lot of sleep. I'm feeling tired from my brain. You know what? I'm gonna